Orthographic projections. An orthographic projection shows an object in simple two-dimensional views. Objects are held in one or four quadrants. For the purpose of this course, we deal with the first quadrant and the third quadrant. So it is a method of representing a 3D object in two planes. Objects are held in one quadrant and an image projected to represent the object when viewed in a particular direction. The projection usually consists of three views to create the object. They are front elevation, a plan, and L elevation. A left-end elevation is sometimes used to show additional information. So this is a first angle projection. This is where the object is held in the first quadrant. The yellow L seen here is the front elevation. So when the object is viewed directly looking at this L, you'd only see the yellow L. When viewed directly from above the object, you would see the red rectangle and the blue rectangle. The plan is placed below the front elevation. The right end elevation is the green square and the left end elevation is the yellow and purple. So if you look from the left, you'd see that view. If you look from the right, you'd see the view. Third angle projection. So the 3D object here is the same block as seen before. The front elevation remains the same, the yellow L. The plan view, however, which is the blue and red rectangle, is seen above the angle. So where the first angle projection, it goes below, like when you view the object, you push it below. In third angle projection, is like opening out the views of the object. So the right end elevation stays on the right hand side and the left end elevation stays on the left hand side. The view with the purple as seen below is rarely used. So this is another example of a first angle projection. So you could see the front elevation with the red block there and the two blue sides, the right end view and the plan view or top view in this case. The light drawn lines are orthographic lines. They are used for construction. Normally the spaces between the views are evenly spaced and a 45-degree line transfers the corners or the same part of the object across to the next side. The same goes for third angle projection. So again, you can know the difference. The plan goes on top of the front elevation and the right end elevation remains on the right and the left end will remain on the left. Sections. These are cutting planes through an object for the purpose of showing interior detail. You will not normally see them. Only when you draw a cutting plane through an object, you will draw the hidden detail within the object. So on the right here, you could see the external view of the object. On the left is the cutting plane passing directly through the center. So you could see the internal workings where it has a spring that holds a clamp in place, and when pressure builds up, it pushes this up to release the steam or the pressure. So there are some rules that you want to follow when you're doing a section. So you always hatch where the section line passes through a solid part of the object. Where there are more than two objects, you hatch it, but your hatching is never parallel to the actual interior or the exterior of the object. So you can see here the hatching goes at different angles to two different assemblies and it is not parallel to any of the sides. Same thing for tree, remember. So you have a straight cutting plane as well as an offset cutting plane here. As you can see, the solid part is hatched and the interior working shown. Offset part shows where the cutting plane line, but in the view itself, everything looks like it's a straight line. So you have to depend on the plan where the section line passes to see where the actual section exists. Everything is drawn straight. So you have types of section. A remove section. This is where you have the section line and then above it you have what the actual section looks like. So this part here is a square section, the next one hexagon, and a circular section on the end. A broken section is just a small cutaway from the object showing the interior detail. It's not for the entire object, just to show a small piece. A revolved section. Similar to a remove section, except it remains within the actual object and you just use broken lines to show that is a revolved section. Webbings, ribs, and spokes. So a webbing, although the section line passes through the webbing, it is actually not hatched. If you do hatch it, it would give a false impression of the object or the composition of the object. So webbings tend to remain unhatched. The same thing goes for ribs and spokes. So where you have the spoke passing, it would remain unhatched. Align sections. So it is a little different from an offset section. A line section passes on an angle, but because it is aligned, we tend to draw the part straight up to the center line and then project it downwards. So you don't draw, say the center of the circle forward, it don't go straight down here. You actually draw a curve going up to the center line and then down towards the section view. So in this part you can see that you have a straight section, but you tend to draw the circles aligned. So how you see the circle passing through here and then the other circle, you'd have the two circles or the two circles in the part shown here. It is not recommended that although it is straight, you exclude the circle. It's recommended you pass it through the thing and you depend on the actual plan view to see where the actual placement of the circles are. So this is another example of an aligned section where it passes through here and you rotate it down to the center line and then across. You get a better example of how when you align it to the center and then you carry it across, where it falls. Okay, so this is just notes based on the same thing we just went through.